Hi, let's talk a little bit about Kaboom challenge from Insomni'Hack teaser. It wasn't a very difficult challenge, but it had a nice trick that might trick some of the people. At least it did tricked me. I spent too much time on solving this challenge, so I would like to show you what was the trick and how we could solve this one. So it was reverse engineering challenge, so we could start by loading the file into Ghidra or any other tools, and if we would do that, actually we would be seeing only just an entry function, and if you look through the defined strings, there was not that many strings available, and also if you would see the program trees, there would be those UPX 0, 1, 2 sections that immediately comes to my mind when we see a packed binary. And yeah, I guess what I did was just unpacking the binary, and I guess probably a lot of people did that. And if we would do that, we would get another binary that if we would load to Ghidra, we would get a bit more information here. So it would be a lot more functions, a lot more strings defined, and overall it looks like this is our target. And if you would look at the entry function, we would see I guess standard win main function, which has like main somewhere here. And yeah, analyzing this method is actually not that complex. So we check if the argument passed to this binary is diffused, and then it would be checked if the prefix it would be the prefix would be passed to this function, and the prefix is insomni and curly brace, and this URL is passed to this check flag function. And of course the URL is it's not what we are after. And if we go to this check flag function, it checks if this flag, so this prefix that's being passed, is the same as YouTube link, which of course, well, it cannot be the same because, well, this is constant and this is constant. There's nothing read from the user except for this diffuse argument. So that was a bit interesting. And if the check flag returns 0, then the flag is correct, and we'll print, okay, the flag is this link again. So there's something going on, and yeah, there must be somewhere else the actual checking of the flag. And yeah, for a very long time I couldn't find it. And then I started looking into the packed binary, because I thought, okay, if it's not here, maybe it's somehow UPX has, I don't know, 2 binaries inside it, and you can unpack somehow different binary from this packed file. But it wasn't that. Actually, it was something else. And if we look again at this UPX binary, we would see that there is something interesting being pushed on the stack, and then there is some XORing and adding some values. And if we would debug it in the debugger, so I have the debugger here. Let's just go to the user code, and we have this code here as we saw in Ghidra. And there was like, okay, we push some values, then we add something to CL, we compare it with something on the stack, and those are the values that we compare. And then if it's equal, then we skip this or the L1, and we increase the ESP. And we do it until we reach the 0 pushed on the stack. So this is some kind of, well, yeah, some kind of checks that something that's being passed is equal to some value. and those tags values defined as what the value is. But what actually is being checked here, because this is like packed binary, so there should be no checks here. It should be, yeah, we should not actually execute this binary. I mean, this should be, well, okay, we could execute this binary, but the code that should be executed is just unpacking of this binary. Nothing should be checked. So that was interesting. So yeah, if we put a breakpoint here and we run to this place, we'd actually see that the values that we are comparing, so those ones in the AAX, are the values that, let's just follow that in dump, that are values that are being passed as arguments to this exe file. And I already have the correct values passed here. But yeah, so this is the values that are being passed to the binary. So yeah, so this is interesting. So the packed binary will behave differently depending on the arguments being passed to it. And what's actually happening is that if we pass additional argument to the one that we saw in the dead listing, so the fuse we saw in the dead listing, and if we pass additional argument, which is this please and thank you exclamation mark, the binary will do a bit more work here. So this is the check, so I'm just going through it, that it checks that actually the values are correct. So DL will never be set to 1. And if it's never be set to 1, then we will execute this part. And this part will override parts of the compressed binary with some values. And the values are taken from here. Let's see them in dump. Let's go selected address. And here are some bytes which looked like it might be connected with the challenge, because there is this Insomni here, and yeah, they look like there are some text values, but more or less it's just like a rubbish. But it will override the bytes that are actually used for the compressed binary, and it will be done for quite a few bytes. So it's 11A1 hexadecimal values. So we can just skip that, and we will get those bytes overwritten over the compressed binary. And only now it makes sense to decompress, because we will get actually a bit different assembly than what we would get if we wouldn't pass this additional please and thank you argument. And we can skip that also. Let's see if I have a breakpoint. I have a breakpoint here, so I can skip to it. And now I'm in the decompiled, the decrypted, unzipped binary, and now it will behave differently. So let me just find out the place where the check for this diffuse was, and I will just put a breakpoint there. So let's just minimize this virtual machine, and let's just open, so where we have Ghidra. Okay, this is the Ghidra, and we have here the comparison with the diffuse. So let's just go to this address, and let's just put a breakpoint there. So Control G will already probably have some address, but it's wrong. 06B 6D. Okay, we have an address here. Something wrong. Did I incorrectly wrote the address? Okay, I don't want to follow in dump. I want to follow here. Okay, 406B6D. Okay, this makes more sense. Let's put a breakpoint here, and let's just go back to this one. And we are here. So now, okay, the comparison with diffuse is still the same. So we are comparing diffuse with diffuse because we passed this argument. That's correct. And we skip this one. Now we have this Insomni that's being passed to string length. So this is fine. We get the 4 characters. And now we no longer have a link. We have this actual flag. So this ins, GG, easy, clap, poke, U, 5, head, B, and so on and so on. And we can actually see it in the dump. Is this the correct address? Yes. There's also a heart and closing brace at the end. So this is the actual flag, and if we go through a few more lines, we'll skip to here, and this call will display for us congrats. The flag is this strange set of characters which I cannot probably read. So that was quite interesting challenge. So yeah, I guess the trick was that not to believe that UPX is just UPX, and you should unzip the file, or just extract the file that's inside this UPX. There might be something more. So that was a bit tricky for me. I spent too much time, way too much time on finding out this trick, but yeah, in the end the challenge was solved, so I'm quite happy about that. Okay, and that's all for today. I hope you like this shorter video. So yeah, if you have any comments, just let me know, and see you next time. Bye bye.